Hey, we got a video here that's going to be solving multi-step equations, and this is going to be the 3 steps. It should say 3 right there. These are going to be the 3 steps that you need to do in order to solve multi-step equations. Let's look at the green one first. The green one here on the right. -4 plus 5g is equal to 6. Okay, first off, we're supposed to simplify. And if we look at that, there's nothing we can simplify there. Simplifying would mean, like, maybe if we had 8 right there, 8 minus 4 would be 4. That would be simplifying. But let's look at the what we have to do. We have to simplify is number 1. Number 2, move the variables to one side of the equal sign. So we would move this variable to one side of the equal sign, and it looks like it's the only variable, so it's probably going to stay there. And the numbers without variables to the other side. Well, if this is where the variables are, if they're on the left side of the equal sign, then we need to move the numbers without variables to the right side. So somehow we need to get this 4 shipped over there with the 6. And then how do we do that? Well, we use opposite operations to do that, to get the variable alone. So, well, let's go through the steps and figure out how we do that. First off, simplifying. Like I said, there's no simplifying to be done. So let's move the variables to one side of the equal sign and the numbers without variables to the other side. So basically, let's look at what we have here. This is what we have. We have, from our order of operations video, we have grouping symbols as first. Then we do exponents, multiplying and divide from left to right, addition and subtraction from left to right. And that's our order of operations. Now, when we're trying to solve for a variable, instead of coming this way using order of operations, when we're solving for a variable, we go backwards through the order of operations. And that's the reason why simplify is first. There's no simplifying to get rid of. Now, addition and subtraction. Is there any addition and subtraction that's taking place to the g? Well, you might say, well, I see a plus 5. Well, that's not plus 5 plus g. That's positive 5 times g. So that's multiplication. That would be right here. That's the next step up. So we can, we're not adding 5 to g. We're multiplying 5 to g. So any addition or subtraction, this right here, this is a subtraction. And you might say, that looks like a -4. Well, remember the properties we learned about here. You could take 5g and you could write plus -4, or you could put 5g minus 4. And if you wanted to rearrange that, well, now it looks like now you're subtracting 4, right? But this is why you need to pay attention and just get used to seeing it this way. Just realize that that -4 right there is like a subtracting 4. You're taking 4 away from whatever 5 times g is. So, like I said, working backwards through the order of operations, there's no addition, but there is a piece of subtraction. And how do we move -4 from here over here with the 6? Well, it says use opposite operations. So what's the opposite of -4? Positive 4, right? And positive 4. So basically, I've just added 4 to both sides. That's like saying if I had 10, which is equal to 10, if I added 4 to this 10, I'm going to get 14. That's not equal to 10. So how can I get this second 10 to equal 14? Add 4 to it. And now they're both equal to 14. You see, we've done the same thing to both sides of the equal sign. We've done the same thing to both sides of the equal sign. So, if you're looking here, here's the equal sign. We've added 4 once. We've added 4 to the right side. We've added 4 to the left side. So now we have a balanced equation still. The left side is still equal to the right side because we've added 4 to both sides. Now let's go ahead and figure this out. Positive 4 minus 4, that's going to give us 0, and 0 plus 5g. That's equal to 6 plus 4, which is 10. Now you're going to get used to seeing equations like this and trying to solve them. You realize that 0 plus 5g is 5g. And remember, the positive sign's out there in front, but we don't need to have it out there because it's a positive sign, and we can leave that invisible. Drop everything else down. 5g is equal to 10. So now we've gotten rid of subtraction. Now that we're working backwards through the order of operations, multiplying and dividing, is there any multiplying and dividing that's taking place towards the g? Well, we said earlier it was 5 times g, right? 5 times g. Well, what is the opposite operation of multiplying by 5? The opposite operation of multiplying by 5 is dividing by 5. When we divide by 5, remember you have to divide by 5 on both sides of the equal sign. And I just drew that line in there so you could tell that that would be both sides of the equal sign. So now we're working with 5 times g over top of 5. And if we were to have the fraction 5 over 5, what does that equal? Well, that equals 1. And a lot of times you'll just see me cancel those out, and we're going to cancel those out and write g, because what number is in front of that g? Do you see a number in front of g? You don't see a number, but you should know that there is a number there. That would be the invisible 1. The invisible 1 is in front of g. And that's what you're trying to do. You're trying to get g all by itself. You're trying to get the variable alone, but in actuality, it's always got an invisible 1 in front of it. But it looks like it's alone. You see how it looks like it's alone down here? So that's what you're trying to do. You're trying to get it alone. We drop down our equal sign, which is g equals, and then we drop down whatever this is. What is 10 divided by 5? Well, that is 2. G is equal to 2. Are you correct? Well, it's real easy to tell if you're correct. And we got rid of all the multiplication and division. I'm looking at order of operations. There's no exponents and no grouping symbol to get rid of. So let's check and see if we're correct. Well, if g is equal to 2, we're going to plug it right in here for g. We're going to put a 2 there. Let's put a 5 there. And our negative 4. Follow your order of operations now, because we're working a problem. We go through the order of operations the way you've always gone through them, the forward way. So what's positive 5 times positive 2? Well, that's a positive 10. And negative 4 plus 10, negative 4 plus 10 is going to be a positive 6. And if you notice, those are the same. So therefore, you have the correct answer. And whenever you solve these problems, you're always able to plug in your solution there and check to make sure that you have it correct. And if you do, then you're good to go. You have it right, you can move on. If you don't, you should probably look back through and try to figure out where you made your mistake. Let's look over here at the other one. Simplify. Okay, there's no simplifying because you can't combine 2x and 6. They do not have like terms. Okay, so now that we're done with simplifying, let's look at the next part. Step number 2 says you're supposed to move the variables to one side of the equal sign. Well, I have an x over here and I have an x over here, so I have an x on both sides of that equal sign. Now let's look at our numbers without variables. Our numbers without variable is that negative 6, and if you notice, it is on the left side of the equal sign. So I want to go ahead, since I am going to have to take the number without variable on the other side, away from the number with a variable, I'm just going to leave negative 6 on the left side, and I want to try to send this 2x over to the right side. So, how do we do that? Well, we can do that by using opposite operations. This 2x, if we notice, this 2x, remember, is a positive 2x. So what is opposite of a positive 2x? That would be a negative 2x. And you notice, if I subtracted 2x, or I said negative 2x, but you have to remember that negative 2x is the same as subtracting 2x. If I subtract 2x from the left side of the equal sign, what do I have to do to the right side? Subtract 2x again. So we subtracted 2x from both sides of the equal sign. So looking here, positive 2x minus 2x, they actually make 0x, and 0 times x is 0, and we know that 0 minus 6 is negative 6. So a lot of times you won't even put this part that I just circled. A lot of times you won't even write that. You'll just drop that negative 6 down. Drop down your equal sign. And what's 9x minus 2x? 7x. So now we keep working backwards through the order of operation. Is there any addition and subtraction that's taking place towards the variable? Well, if we look over here, the negative 6 is not on the same side as the variable. So we are not subtracting 6 from 7x. We just know that negative 6 is 7x. So there's no addition or subtraction. How about multiplying or dividing? Well, there's no dividing, but we are multiplying by 7x, correct? So if we're multiplying by 7x, we have to look at opposite operations. And what's opposite of multiplying by 7x? Or I'm sorry, what's opposite of multiplying by 7? That would be dividing by 7. And a lot of people want to put 7x down there on the bottom. This is a no-no. You don't want to put that x there. No, no, no. That would be a bad deal, because that right there is not what we're supposed to have like this. When we do it like this, the 7's cancel out, and we're left with only an x. Now, if we come back over to what I had showed you, if you look at this, and if you have something that's the same on top and bottom of a fraction, that just equals 1. Because really, the 7's cancel out and the x's cancel out, and you're left with 1. So that's the reason why you don't put the x on the bottom. And plus, if you put x on bottom here, you would have to divide by 7x over here, and that just causes a whole bunch of issues, because then you have negative 6 over 7x is equal to a 1. And we really haven't gotten the x by itself. We just kind of made it look a lot messier. So since we divided by 7 here on the right side, you have to divide by 7 on the left side. And so therefore x is equal to negative 6 over 7, or negative 6/7. And you can plug that back in and check it if you wanted. 2 times negative 6 over 7 minus 6 is equal to 9 times negative 6 over 7. Remember, when you multiply fractions, both of them have to be a fraction. We know a positive 2 over 1 times negative 6 over 7 is a negative. We know that you multiply the top number, so 2 times 6 is 12. And you multiply the bottom numbers, 1 times 7, that's 7. You're subtracting 6, and we're multiplying again. So we have 9 over 1 times negative 6 over 7. Positive times a negative will give you a negative. 9 times 6 is 54. 1 times 7 is 7. Now we're looking at the left side. We have negative 12 over 7 minus 6. Well, we have to have common denominators here. We have to have common denominators. So Trying to get some of this out of your way. Common denominator. So if we have a 12 over 7 and we have a 6 over 1, because remember this 6 is over 1, how do they have common denominators? Well, I know that if I multiply 1 by 7, I'm going to get 7, and therefore the denominators then are the same. But if I multiply down here 1 by 7, I got to multiply 6 by 7. That gives me 42. And now we have common denominators. I do not have to change that top fraction, 12 over 7. So I have negative 12 over 7 minus 42 over 7. And negative 12 minus 42 is going to be negative 54. And the bottom number stays the same. And if you notice, those are the same. So therefore you have the correct answer. You have the correct answer. Okay, so now you have a pretty good idea on how to solve a multi-step equation for a variable. Let's go through and work through some problems here. All right, first step, simplify. There's no simplifying because 4x and 3 are not like terms. So now you're supposed to have the variable on one side and the numbers without variable on the other side. So here's the variable. It's already on one side of the equal sign. And we have to move the numbers without variables, which would be the 3. See, you are adding 3 there. There's no subtracting to the variable, but you are adding 3 to the variable. So using opposite operations, what's the opposite of adding 3? You minus 3. Now remember, here's the equal sign, right? If you subtract a 3 from the left side, you have to subtract 3 from the right side. It's very, very important that you subtract the same number from both sides. I hope you're paying attention to that, because if you don't, then you're going to get some wrong answers. So positive 3 minus 3 cancel out and give you 0. And we know that 4x plus 0 is just 4x. And then on the right side of the equal sign, we have 11 minus 3. 11 minus 3 is 8. So we don't have any more addition to the variable. We have no division to the variable x, but we do have a multiplication of 4. What's the opposite of multiplying by 4? Dividing by 4. And make sure you're only dividing by 4 down there, not 4x. You're only dividing by 4. 4 divided by 4 cancels and gives you a 1, and then the x stays there. What is 8 divided by 4? That is 2. And this one's a pretty easy one. You can think about plugging 2 in right there. What's 4 times 2? That's 8, and you add 3 to it. That's 11. You have the correct answer. Nice work. Okay, here's one. I want you to try this one on your own and work out the solution on your own. Pause the video, and then when you get done, hit play and make sure it matches mine. Simplifying. There's no simplifying. 5x and 35 are not like terms. Addition and subtraction, well, you're subtracting 35. So how do you get rid of 35? How do you get rid of subtracting 35? You add 35. Now remember, you have to add 35 to both sides of the equal sign. Here's the equal sign. 35 on the right side, 35 on the left side of it. So let's drop down. 5x, negative 35 and positive 35 cancel. Here's our equal sign. 0 plus 5 is 5, and 9 plus 3 is 12. So we've gotten rid of all addition and subtraction that's happening against the x. And remember, we're working backwards. Multiplying and dividing, there is multiplication, no division. How do you get rid of multiplying by 5? You divide by 5. You divide by 5. Cross off the 5s. 5 over 5 is 1, and remember this is an invisible 1x, an invisible 1 there. So now we know x is equal to, how many times does this bottom number go into the top number? I believe it is 25 times. And therefore, x is equal to 25. This one here, you have 1/2 t minus 9 is equal to 11. Just because it is a fraction, you still do it the same way. Simplify. You cannot simplify because 1/2 t and -9 do not have a like term. Addition and subtraction. I believe you are subtracting 9. So you're subtracting 9 from the variable t, but it's 1/2 t. So how do you get rid of subtracting 9? Add 9. Here's your equal sign, so you have to add 9 to the left, which we've already done. Add 9 to the right. -9 plus 9 cancels, and now we are left with 1/2 t. And that's equal to, what's 11 plus 9? 20. 11 plus 9 is 20. Subtraction's gone. We know there is no division happening towards t, but there is multiplication. You're multiplying t by 1/2. So 1/2 times t is what number? Or I'm sorry, 1/2 times t is 20. So what's the opposite of multiplying by t? The opposite of multiplying by t, t by 1/2 is dividing by 1/2. Now, this is the part where there's two ways to solve this, and if you know how to work with fractions, the second way I show you is going to make sense. And if you don't know how to work with fractions, hopefully that you pay attention enough that you're going to understand it, and soon enough the second way will make sense. Let me show you the first way, the way that you're used to. So you divide by 1/2 on both sides. 1/2 divided by 1/2 cancels and leaves you with 1 t. Now we have 20 divided by 1/2. 20 over 1 divided by 1/2. And let me slow down here. I know I said we have 20 divided by 1/2. That's what we have right there. And anytime that you have a number without a fraction, you can always put it over top of 1, and then you have it in a fraction. So now, how do you divide fractions? Well, what you do is you multiply by the reciprocal. The first fraction stays the same, 20 over 1, and then I said you multiply by the reciprocal. What's the reciprocal of 1/2? Reciprocal is when you flip the fraction. Instead of 1/2, it becomes 2 over 1. So now we have 20 over 1 times 2 over 1, and we multiply straight across. What's 20 times 2? 40. And 1 times 1, which is 1. And anytime you have a number over top of 1, it's just that number. 40 over 1 is equal to 40. And so therefore, we have 40. T is equal to 40. All right, this right here, this part right here, where you multiply by the reciprocal, if you can start remembering, hey, I have a fraction at this part. Let's see if I can erase some of this. If you can think, hey, I have a fraction at this part, instead of going through dividing, writing it down, and then showing that you're multiplying, you can just say, well, I know I'm going to divide by 1/2, but when I divide by 1/2, that's the same as multiplying by the reciprocal of 1/2. What's the reciprocal of 1/2? 2 over 1. And you know that if you have 2, and you multiply it by half, well, what's half of 2? Half of 2 is 1. And so we have 1t. So keep that in mind, 1t. And multiply by 2 over 1 on the right side. You multiplied by 2 on the left side, so multiply by 2 on the right side. So 20 over 1 times 2 over 1, 20 times 2 is 40. 1 times 1 is 1. T is equal to 40. And that's the answer we got last time. The thing is, we just didn't do all of this work over here. We thought about it first and realized that when you divide by fractions, it's the same as multiplying by the reciprocal. The concept you're going to have to focus on and just remember happening. Okay, I will let you solve this one here in a minute. Let me help you simplify. This one needs simplified first, and then I'll let you go solve it on the rest of it on your own, because after we simplify it, it's just like the last problem, just different numbers. So let's look here. Once we have this 3/4 outside the parentheses, we do have to simplify. So how can we do that? Two ways to do it. First way, you have 3/4 outside the parentheses. You have r plus 6 is equal to 12 inside, or r plus 6 inside the parentheses, and all that's equal to 12. First off, you could say, well, you could distribute if you wanted to, in which that's going to be the second method that I'm going to show you. First method I'm going to show you is, well, here is the variable. How can we get rid of this 3/4 outside? Well, you get rid of 3/4 by I guess dividing by 3/4. But remember, dividing fractions means you multiply by the reciprocal. So let's go ahead and multiply by the reciprocal, 4/3. And we notice that 4 times 3 is 12, 3 times 4 is 12, and that's equal to 1, which once we have this parentheses of r plus 6, we have an invisible 1 in front of it. And when that invisible 1's there, we can distribute it through everything inside, and we just get 1 times r plus 6. But remember, if you multiplied by the reciprocal on the left side, you have to multiply by the reciprocal on the right side. 12 times 4 is 48, and divided by 3. Or you could say, I know 3 goes into 3 one time, and I know 3 goes into 12 4 times. Now we have new fractions. 4/1 times 4/1, which is easy. 16/1, or just 16, because we don't need to say that it's over 1. 16. I hope you are capable of understanding the fractions. I know it's, if you understand fractions, this goes fairly quickly. That was the one method to do it, and then of course simplifying's done. You need to get rid of the addition, but there is no subtraction, so once you subtract 6 from both sides of the equal sign, r is equal to r is equal to 16 minus 6, which is 10. That's one method of doing it. The other method I showed you, I was going to let you solve that one, wasn't I? Maybe the next one you can do on your own. The other method I was going to show you was 3/4 times r, 3/4 r, and 3/4 times 6. Well, if you think of 3/4 times 6/1, you know that 2 goes into 4 twice, and 2 goes into 6 3 times. You cannot cancel and say 3 goes into 3 once and 3 goes into 3 once. You can't do that now, because if you're going to reduce when multiplying fractions, one of the numbers has to be on bottom and one of them have to be on top. It can either be like that, or it can be like 2/4 times 2/3. Like you could cancel this one with this one. 2 goes into 4 twice, 2 goes into 2 once. You can cancel those, and then you can even cancel a second time. 2 goes into 2 once, it's on top. 2 goes into 2 once, that's on bottom. As long as you have a number that's on top and a number on bottom, you can cancel those. And you notice now we're working with smaller numbers. 1 times 1 was 1, and 1 times 3 is 3. That's 1/3. Let's go back to what we're working on, though. What we're working on now is 3 times 3, which is 9, and 2 times 1, which is 2 times 1, which is 2. 9/2. 3/4 times 6 is 9/2. That's equal to 12. And now that we're here, Let's erase this. Now that we're here, simplifying is done. There is addition but no subtraction happening to r. So now, how do you get rid of a positive 9 over 2? You subtract 9 over 2. If you subtract 9 over 2 from the right side, you have to subtract it. If you subtract 9 over 2 from the left side, you have to subtract it from the right side. This is what we have. Well, we know 9 over 2 minus 9 over 2 is 0, and we're left with 3 over 4 r, and that's equal to, and once again, we're back to common denominators. Common denominator between 1 and 2 is going to be 2, and this one's already, the bottom fraction's already set up to have a denominator of 2. So therefore, 1 times 2 is equal to 2, and if you multiply the 1 on bottom by 2, you have to multiply the 12 on top by 2. That gives you 4. So therefore, what we really have is 4 over 2 subtract 9 over 2. 4 minus 9 will give you negative 5. And 2 on bottom stays 2 on bottom. So we have negative 5 over 2. 12 minus 9 halves is negative 5 over 2. And I think that's a little bit wrong. Let's see if I can bring that back for you. Yes, it is a little bit wrong. 12 times 2. There we go. Glad I caught that. 12 times 2 is actually 24 over 2. And now that makes sense. That makes better sense. 24 minus 9 is not negative. 24 minus 9 is a positive 15. Positive 15 over 2. Positive 15 over 2. All right. Now, addition is gone. There is, we're not dividing anything. We're not dividing r by anything, but we are multiplying it by 3/4. Now, we could divide it by 3/4. The opposite of multiplying by 3/4 is dividing by 3/4. But remember, when you divide by a fraction, it's the same as multiplying by the reciprocal. If you did that on the left side, you have to do it on the right side. Now, let's cancel some things. 4 goes into 4, and it leaves us with 1s. 3 goes into 3, 1 time. And so when we multiply, we get 1 on top, 1 on bottom, and that leaves us with the invisible 1, 1 times r. That's equal to, what can you simplify on the right side here? Do you see something on top with something on bottom that you can cancel? I see 2 and 4. So what number goes into 2 and 4? Well, 2 does. How many times does 2 go into 2? Once. And how many times does 2 go into 4? Twice. Anything else there we can cancel? How about 3 and 15? What number goes into 3 that also goes into 15? 3 does. So 3 goes into 3 once, 3 goes into 15 5 times. And multiply straight across. That doesn't really look straight, but I don't want to draw the line through everything else. 5 times 2 is 10. And on the bottom, 1 times 1 is 1. We don't really need to put that 1 there because 10 over 1 is just 10. So there's your answer. R equals 10. I kind of like the first method better because we got rid of the fraction first and we didn't have to work with very many fractions at the very beginning. Now you can only do that if you have the fraction outside of the parentheses. If it would have just been 3/4 r plus 6, or you can't just multiply by the fraction first because there's no parentheses there. So r equals 10. Let's look at this next one. This one I will let you solve out. I'll let you pause it. I promise. I'll stop this time. Simplifying. You can simplify. Look at the equal sign. You can't do anything on the left side with 41. But on the right side, look at like terms here. We have a positive 3x and a negative x. So if we kind of put those together and think about it, 3x minus x is going to be 2x. And then bring down your 15. That's a positive 15, so I'm going to put plus 15. That's equal to 41. So see what you can do there. See if you can go ahead and solve that out. You're trying to get x by itself. Got simplifying out of the way. We know that there is addition, no subtraction there. So you go ahead and figure it out, pause the video, and then hit play and check to see if how you're doing. All right, I'm going to work through this one. We have to get rid of the addition, so the opposite of adding 15 is minusing 15. And if we did that to the right side, we also have to do it to the left side. Okay. So 41 minus 15, this becomes 11, this becomes 3. Because I'm borrowing, because of 1 minus 5 you can't do. 11 minus 5 is 6, 3 minus 1 is 2. That's 26, which is equal to 2x. Addition is gone. There is no division, but there is multiplication. What's the opposite of multiplying by 2? Dividing by 2, and those cancel. You have to divide the left side by 2 also, and we get 13 is equal to x. Multiplication is gone, and of course no exponents, no grouping symbols we have to get rid of. There's one, and this is the last one. So what I want you to do is I want you to try this one on your own. This one has, like, I think 2 steps of simplifying to do. So you try this one on your own and see what you can do. Hit pause and then play it when you're finished and check your solution. Okay, let's look at this. Simplify. Let's simplify. First, I want to distribute. And remember that this is a -4 that you're distributing here. Okay, it's not just 4. There's a negative sign with that 4. So -4 times -3x. We know a negative times a negative is a positive. 4 times 3 is 12. And you're not multiplying x with anything, so you just put the x there. -4 times +2. A negative times a positive is a negative. And 4 times 2 is 8. And we drop everything else down. Like I told you before, there was a couple steps of simplifying. So distributing that -4 was the first step. The second step, combining like terms, 6x and 12x. Those are like terms. 6 plus 12 is 18, and the like term of x. Drop everything else down. And now we're just back to trying to get the variable by itself. The variable is on the left side, so let's move the numbers to the right side by using opposite operations. The opposite of subtracting 8 was adding 8. Those cancel. And you drop down 18x. And 10 plus 8 on the right side is 18. So we've done simplifying. We've gotten rid of addition and subtraction towards the variable. And now we're looking at how do we get x alone? Well, we are multiplying 18 by x. There's your multiplication. So how do you get rid of multiplication? Division. 18 divided by 18 will leave you with 1x. And 18 on the right side here, 18 over 18 is 1. And there's your final solution, x equals 1. Well, this is all we have for this video. I hope you can take this and apply it into the work that we're going to be doing. So I will see you in the next video.